Now we are going to discuss about the rational numbers chapter 1 class 8. This is the first chapter in the class 8. Before going to discuss about the rational numbers, go through the number system what we have learned in previous classes. So we already learned about natural numbers. Natural numbers means the counting numbers start from 1, 2, 3, 4 and 5 and so on. These are called natural numbers. And whole numbers. The whole number set contains the counting numbers along with the 0. This set is called whole number set. And these are starting from 0, 1, 2, 3, 4, 5 and so on. And integers. Integers means negative numbers and whole numbers. And it is also negative numbers and 0 and positive numbers. These are together called integers. They are represented as 0 is in middle and from right side we have the positive numbers and on left side we have the negative numbers. On right side we have the countless numbers and on left side also countless negative numbers. And rational number. This is the number set which we are learning in this class 8 chapter 1. So definition is states that the numbers which can be written in the form of p by q, where p comma q are the integers, and condition is that q should not equal to 0. Here q is in denominator, so denominator should not be equal to 0. So the numbers which can be written in the form of p by q and the denominator is not equal to 0, then such kind of numbers are called rational numbers. So now we represent these numbers diagrammatically. So first natural numbers means 1, 2, 3, 4, 5. We already know that whole numbers means including 0 and natural numbers called whole numbers. Means all natural numbers also whole number set. Next integers. Integers have negative numbers and positive numbers and whole number. Means integer is a set of numbers which are negative numbers and whole numbers. And rational numbers. Rational numbers means the numbers which are written in the form of p by q, where p comma q are integers and q not equal to 0. Means here from this diagram we can say that natural numbers also rational numbers and whole numbers also belongs to rational numbers and integers also belongs to rational numbers. So here rational numbers are 5 by 6, 9 by 4, minus 7 by 6 and minus 3 by 8. These are the in the form of p by q, where here denominator is not equal to 0. So all natural numbers also rational numbers, because all natural numbers are 1, 2, 3, 4, 5 and so on. These numbers are written in the form of 1 by 1, 2 by 1, 3 by 1, 4 by 1, 5 by 1. Here denominator is not equal to 0. That's why all natural numbers also rational numbers and all whole numbers also rational numbers. Why? Because the whole number 0, 1, 2, 3, 4, 5 and so on are also written in a p by q form as 0 by 1, 1 by 1, 2 by 1, 3 by 1, 4 by 1 and 5 by 1 and so on. Next, all integers also rational numbers, because all negative numbers and 0 and positive numbers are written in the form of p by q form as minus 5 by 1, minus 4 by 1, minus 3 by 1, minus 2 by 1, minus 1 by 1, 0 by 1, 1 by 1, 2 by 1, 3 by 1, 4 by 1, 5 by 1 and so on. So that's why all integers are also rational numbers. So from this we can conclude that all natural numbers and all whole numbers and all integers are also rational numbers, because they can be written in the form of p by q, where q is not equal to 0. So in this chapter we learn three main concepts. First one properties, and the second one is representation of rational numbers on number line, and the third one is how many rational numbers are between two rational numbers. So first we discuss about properties, what we are going to learn in this chapter. So first one is closure property, and second one is commutative property, and third one is associative property, and the fourth one is identity property, and the fifth one is inverse property, and the sixth one is distributive property. So first property is closure property. We learn the closure property of natural numbers, whole numbers, integers and rational numbers with respect to the basic operations: addition, subtraction, multiplication and division. Similarly, we learn about commutative property of natural numbers, whole numbers, integers and rational numbers with respect to the four basic arithmetic operations: addition, subtraction, multiplication and division. Next, third property is associative property of natural numbers, whole numbers, integers and rational numbers with respect to four basic operations: addition, subtraction, multiplication and division. Next, fourth one is identity property of natural numbers, whole numbers and integers, rational numbers. We have two properties. One is additive identity property and multiplicative identity property. Next is inverse property. Inverse property of natural numbers, whole numbers, integers and rational numbers. We have two inverse properties. One is additive inverse and second one is multiplicative inverse. Additive inverse is nothing but negative of a number, and multiplicative inverse means reciprocal of a number. So sixth one is distributive property. Distributive property of multiplication over addition, distributive property of multiplication over subtraction. Second topic which we are going to learn in this chapter is representation of rational numbers on number line. So first one is natural numbers. Natural number set. How to represent natural number set on number line. So natural numbers line starts from 1 and continues on right side. So the line extends indefinitely only to the right side of 1. This is the representation of natural numbers on number line. Next, second one is whole numbers. Whole numbers start from 0 and this line extends indefinitely only to the right side of the 0. Next, third one, representation of integers on number line. So in the middle we have 0, on right side we have the positive numbers and left side we have negative numbers. This line extends indefinitely on both sides of 0. Positive numbers on right side and negative numbers on left side. Next, rational numbers. Rational numbers represented on the number line as follows. Here we have other numbers between the integers. We have 1 by 2 between 0 and 1 and minus 1 by 2 is between 0 and minus 1, and the line extends indefinitely on both sides of 0 and numbers between 0 and minus 1 and 0 and 1. So this is how we represent the different numbers on a number line. Now we are going to go through the third topic. How many rational numbers are between two rational numbers? Before going to discuss about this one, we go through some examples. Can you tell the natural numbers between 1 and 5? Yes, we can tell. There are numbers between 1 and 5 are 2, 3, 4, which are the natural numbers between 1 and 5. No other natural numbers are between 1 and 5 other than 2, 3, 4. Next, how many natural numbers are between 7 and 9? So we already know that 8 is only one natural number which is between 7 and 9. Next, how many natural numbers are there between 10 and 11? We already know that there is no other natural number between 10 and 11. Next, list the integers that lies between minus 5 and 4. So we already know that minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3 are the integers which are between minus 5 and 4. No other integers between these numbers. Next, how many integers are there between minus 1 and 1? We already know that 0 is only one integer that is between minus 1 and 1. Next, how many integers are there between minus 9 and minus 10? We already know that there is no integer between minus 9 and minus 10. So from the above we can say that exactly how many numbers of natural numbers or whole numbers are integers between them. So therefore we can say that definite number of natural numbers between two natural numbers. We can say that there are definite number of whole numbers between two whole numbers, and we can also say that there are definite number of integers between two integers. So from the above example we can say that exactly how many natural numbers and how many whole numbers and how many integers are between the given two integers or whole numbers or natural numbers. So next, how many rational numbers are there between 3 by 10 and 7 by 10? Here 3 by 10 and 7 by 10 are the rational numbers. So case 1. Now we go through the different possibilities. So first possibility, between 3 and 7 we have 4, 5, 6 as the numbers. So 4 by 10 and 5 by 10 and 6 by 10 are the three rational numbers between 3 by 10 and 7 by 10. Next, second possibility, that 3 by 10 can be written as 3 into 10 by 10 into 10, which is equal to 30 by 100. Means 3 by 10 equivalent number is written as 30 by 100, and equivalent of 7 by 10 is written as 7 into 10 by 10 into 10, which is equal to 70 by 100. So from these two numbers we can write that 31 by 100, 32 by 100, 33 by 100 and so on up to 69 by 100. These are the rational numbers which are between 30 by 100 and 70 by 100. So from the above we can say that there are 39 rational numbers between 3 by 10 and 7 by 100. Next, third possibility, that how many rational numbers are between 3 by 10 and 7 by 10. So if we write the equivalent number of 3 by 10 as 3 into 100 by 10 into 100, which is equal to 300 by 1000, and we can write the equivalent number of 7 by 10 as 7 into 100 by 10 into 100, which is equal to 700 by 1000. So from these two we can write that 301 by 1000 and 302 by 1000 and so on up to 699 by 1000. These are the rational numbers which are between 300 by 1000 and 700 by 1000. So from these we can say that there are 399 number of rational numbers between 3 by 10 and 7 by 10. Next, fourth possibility is that if you write equivalent number of 3 by 10 as 3 into 1000 by 10 into 1000, which is equal to 3000 by 10,000, and equivalent number of 7 by 10 is written as 7 into 1000 by 10 into 1000, which is equal to 7000 by 10,000. So from these two equivalent numbers we can write it as 3001 by 10,000 and 3002 by 10,000 and so on up to 6999 by 10,000. These are the rational numbers which are between 3000 by 10,000 and 7000 by 10,000. So from this we can say that there are 3999 number of rational numbers between 3 by 10 and 7 by 10. From the above situation we get three rational numbers between 3 by 10 and 7 by 10 in first example. Next, in second situation we get 39 rational numbers between 3 by 10 and 7 by 10, and in third situation we get 399 rational numbers between two rational numbers 3 by 10 and 7 by 10, and in fourth situation we get 3999 rational numbers between 3 by 10 and 7 by 10. So from these all above examples we can say that there are uncountable rational numbers between any two rational numbers. This property is also called density property, means we can have uncountable number of rational numbers between two given rational numbers. Please like, share, subscribe our channel for latest updates by pressing the bell icon.